Assalamu alaikum wa rahmatullah, and good afternoon to all of our respected viewers of Voice of the Cape's Facebook page as well as the VOC's YouTube page. My name is Amir Adams, and I will have the great honor and privilege once again of introducing our VOC's annual Matric revision program in collaboration with Futures Academy SA's online high school. So today, inshallah, we will be going through mathematics grade 12 and particularly pertaining to paper 1 and the preparation that all of you are matriculant students will have to go through for the algebra for your paper 1, that is your upcoming paper for the trial examinations, inshallah. Once again, as always, as I request all of you, our beloved viewers, day in and day out, whenever we have these sessions, please share this and forward this to all of those matriculants in your family and the friends, your friends that you have while in matric. Please ensure that all the matriculants out there gets this much needed content in order that they may adequately prepare for their matric examinations, inshallah ta'ala. Without further ado, we now hand over once again to our beloved brother Imad Isaacs, who is from the Futures Academy SA Online High School, and he will be going through the content for this paper, that is mathematics, paper 1, and particularly dealing with algebra. Without further ado, we hand over to Brother Imad, inshallah.
Okay, shukran so much, Brother Amir. Assalamu alaikum, good afternoon or good evening, almost evening once again, and welcome to the revision program. So we are continuing from the last session that we've had, and that session was on looking at paper 1, particularly focusing on algebra and working on what are the collectible marks. Now, these collectible marks are really all the giveaway marks, but we also want to make sure that the sessions that we do over here is very useful, or the sessions are useful in the sense that we want to focus on the things that are easy enough that you must get, but we still find that students are sometimes not getting it. Okay, so I think in the previous session we covered quite a bit of things. We went over some of the common errors. We went over the sections of the paper. We also looked at the fact that algebra is a section consisting of 17%. And that 17% is really giveaway because it's work you've done in grade 11, it's work you were exposed in grade 8, grade 9, grade 10, and of course, grade 11 as well. Okay, we went over the various cognitive levels, and we also spoke about what are the examples of knowledge, routine, complex procedure problems. Remember, the knowledge questions was a straight recall, easy things that you can immediately remember, and often very easy things from previous grades, right? And then the routine procedures are all those step-by-step things that teachers are teaching you, and the complex procedures were the combination of multiple routine procedures appropriate for that grade level. Okay, and then we described a problem-solving question as the question that in all likelihood we have to have our 99% learner or our 90+ percentage learner stopping, thinking, and having to relate familiar knowledge in unfamiliar contexts. And that was problem solving. Okay. We also went over the strategy for solving algebraic questions. So generally in question 1, you are given questions in which you need to solve for x. Now, there were 2 nevers that we looked at. The nevers were, we never want to work really with fractions. So ideally, when you get a question that has a fraction in it where it's solved for x, you need to get rid of that fraction. And the way we do that is by using the lowest common multiple and applying it and eliminating the fraction that we see there, right? And then also, we never want to work with surds. So that's where we have a root, and we want to get rid of that. So there are 2 steps involved there. Step number 1 is we must isolate the root. And step number 2 is that we must then solve the equation. Okay. Now, when moving towards solving the equation, how you do so is by writing in standard form and then attempting to factorize. And if we cannot factorize, we apply the quadratic formula. Lastly, we also mentioned if the question instructs you to complete the square, then you must complete the square. And the nature of roots is something that we will discuss today. Okay, I didn't really tackle number sense. I'm going to go over a little bit of that before we actually go into our questions related to inequalities, and I'm glad we've included it in the slide. I don't remember us doing this in the last session, but we're going to talk about this. Okay, and then we went through the common errors. Okay, now before we continue, the agenda was actually to look at inequalities. That's what I was thinking about, and to also look at nature of roots. But as I mentioned, number sense is critically important. And yes, if I remember correctly, we did start off with something in number sense. We mentioned the idea of taking a positive plus a positive must give you another positive number. We also spoke about the root of x. Okay, so let me bring up my whiteboard quickly. And perhaps, if we just go to our previous maths one, the math session that we had over there, we can definitely continue with the content related to the number sense. Yeah, we started off on number sense, so there we have it. Okay. So some of the things that we mentioned in terms of the number sense, I want to bring you back to this because this was such an important question in the 2015 examination that we saw so many students not being able to make sense of this. In other words, they were lacking number sense. So two of the important things that I gave you in the last lesson, number one was the fact that the root of x, right, the square root of any number is always greater than 0 or it is 0. In other words, it's either going to be 0 or it's going to be a positive number. Now, similarly, just like the square root in the real number system is always positive or 0, the square of any number is always positive or 0. So here we can see if I take minus 5 and I take that entire negative 5 and I square it, I'm going to get positive 25. Okay. If I take x plus 5 all squared, I must end up with something that is positive. If I take cow squared is going to be positive or 0. Okay. I could have had chicken squared and I'm still going to get something that is positive or 0. So the question that we had to solve in the last lesson where we had x minus 5 all squared plus 3y plus x all squared equals 0, and you had to solve for x and y. So many students looked at this question and said, well, we're sitting with one equation, we have two variables. Now, generally, in a system of equations where I have one equation, two variables, that's not solvable, right? However, when we had to look at this particular question, this would be a little bit of a, I wouldn't even call it really problem solving because it's number sense. We expected to know some things about how numbers work. And so x minus 5 all squared plus 3y plus x all squared equals to 0. It's only possible if I take something plus something else, and both of those things are squared, if each of those things are 0, right? Because if something has to be squared, it can either be 0 or it can be positive. But let's take the argument that this first bracket would have been positive. If x minus 5 took on some value in there that yielded a strictly positive number, in other words, it's not 0, but it's rather a positive number, and let's assume that the other bracket was 0. 0 plus any positive number must yield a positive answer. So that clearly is not going to hold, right? If this bracket was positive and this whole bracket was 0, and I say a positive number plus 0, it's still going to give me a positive number, okay? So if I'm ending up with a positive number, I'm still not ending up with 0. So the only way this equation actually works is if the first bracket is 0, right? So 0 squared will give me 0, and the second bracket is 0. So 0 plus 0 gives me 0, okay? Now, the reason we say that this bracket can only be 0 or positive is coming from number sense. By definition, in the real number system, anything that I square will always end up to be a positive number. Okay, so that was our little introduction that we had in the previous lesson to looking at number sense. Okay, so what we want to do now is we want to add a little bit of rules and just exposure to what we consider in the number sense lessons. Okay, so let us quickly just make something happen here. Just a second. Right. Okay. Okay, so moving forward, I've got a question for you that I want you to think about for all our students that are joining us live once again. Let us look at this question. Let's just see, can a person... Here's a question. What can you tell me about negative x? Okay, so I'm going to bring it up over here. Negative x. And here's a question for you. Question is minus x negative? That's the question. So that's the first thing we want to start off with here, adding to our ideas around number sense. Okay, once again, think of the real number system. Is minus x negative? That's the question. Is minus x negative? That's the question that we have here. Right? Okay, and we see some takers, some students saying it's negative, others saying it depends, right? Okay, so what does it mean by it depends? Now, the reality is when we talk about what negative x is, we say that negative x is the additive inverse, right? So the additive inverse of x, that's what negative x really is. And what does that actually mean? So if I were to talk to you about negative x, then I say negative x is whatever you have to add to x, right? It's something you learned in grade 9. We said x plus negative x is equal to 0. So in other words, whenever I add negative x to anything that is x, then I must end up with 0. And we call this the additive inverse. It means that it's the thing I must add to x to get 0. And that's what some of the solutions, some of the students have sent us here saying it depends. That's what it means, right? So what it depends on is it depends on the value of x. So if I say that if x is equal to 2, then negative x will equal to negative 2, right? Because you take the negative, you multiply it by whatever the value of x is, and you get negative 2. However, we take a similar question. If x is equal to negative 2, then negative x will equal to negative 2, which is equal to positive 2. So as a general rule, something we must make abundantly clear to everybody, it's a common misconception and common error that we see learners make, is that negative x is not negative, right? We need to say that, we need to mention it, we need to stress it. So just be aware, negative x is not negative, right? Okay, negative x is not negative. It depends on the actual value of x. So please keep that in mind. Okay. So that's just something we want to add to our ideas here around number sense. Now, the next thing we want to come to is, we've also told you that the root of any number, the root of anything, the square root, now, sorry about that. No, that's not what I'm looking for. This, I don't know if anybody's watching, but can tell me what happened to my, maybe it's this. Yeah, there we go. Sorry about that, guys. Yeah, we were just looking for what happened to our pens there. Okay, so negative x, we covered that. Now when we talk about a few things, I'm also going to cover domains here, because as we talk about number sense, we need to tackle domains, right? So when we talk about domains, there's a few things we need to look at. Number one, I want to speak about roots, right? So we already started with the number sense aspect to say a root of any number is always greater than or equal to 0, right? It's always greater than, equal to 0 in the real number system. Now, if we consider, let's take a question. Let me see if I have something here. Let's take a question. If you're given a root, and under the root you have some kind of expression, so we're going to say there's an expression, right? We could call that expression chicken or cow, or whatever we want to call it. You've got some kind of expression. Remember that a root is always positive or greater than or equal to 0. So what we mean by this root situation over here is the only way that the entire value over here is greater than or equal to 0 is if the thing under the root is greater than or equal to 0. So in other words, for this to be valid, you must know that the expression under the root, right, must be greater than or equal to 0. This is the condition for validity here. Okay, so that's going to be the condition. So if you were given a function, in other words, you've got a root and you've got some expression under the root, that's known as a function. It's a root function. And they ask you what is the domain of that function. What they're really asking you is what makes that function valid? What value of x is going to yield some kind of output for that function? Well, that will be when the thing under the root is greater than or equal to 0. So this will be your condition. So if ever you have to find the domain of this, you set this up and you solve that inequality. Okay, that's why we're coming to inequalities soon. The next thing is, in the slides over here, let's talk about if I've got a fraction, right? So what about the fraction? Well, you know a fraction is always some numerator, which we've described as a, and some denominator, which we've described as b over here. And for the fraction to be valid, again, the condition is that b, which is the denominator, cannot equal to 0, right? Denominator cannot equal to 0. That will be your domain. It will also be your the limitation in that regard. Okay. If we look at the next one, if we take a logarithmic function, so for example, you've got log of some base, right? Some base, and you've got an expression, okay? You've got a base and you've got an expression. The limitation is that this argument, this parameter that goes into that function must be greater than 0. Because remember, when you look at a log function, it's going to look like this, and everything you see on this side over here, that will be the input that goes over there. And as you can see, it doesn't touch 0, and therefore we see this is greater than 0, but not equal to. Okay, so if ever you are given log of x base 2, and we ask you what is the domain of that, it's going to look like this function, and then the domain of that particular function will be x is greater than 0, right? Because the expression itself must be greater than 0. Not equal to, but greater than, because of this vertical asymptote that we see over here, the y-axis or the line x equals 0. Okay, so be aware of that. Okay, moving on quickly. So I'm not just writing this for fun here. If you don't have this in your notes, it's always good to make some basic notes, because as you write, it also helps you engrave a neural pattern. Okay. Okay. So I just want to switch between that because the hand was disappearing. So if I've got a log function with some base and some expression over here, note that the expression itself must be greater than 0. Okay, so that's for our log function. Okay, now let's move forward quickly. Two unusual cases, we'll tackle this when we deal with. I apologize for this little typo here. In all other cases, x is an element of R. So look out for these three problems. Okay, now let's do a very quick question. And whilst we are on surds and roots, we can look at a question over here. If we are given the following, given that f of x is equal to square root of 2x plus 1. The square root of 2x plus 1. Okay. Now, two questions here. Question number one is give us the domain of this function. Okay. And number two is solve for x if f of x is equal to 2x minus 1, right? So, okay. Okay, so remember when we get these questions, let's start with the first one. The first one is fairly simple. It's asking you, give us the domain. Now we take us back to our number sense rules. We've defined that anything, the root of anything in the real number system will always be positive or it will be 0, right? So for that to be valid, the thing under the root, the entire expression, this thing over here, the thing under the root, 2x plus 1, that entire thing must be greater than or equal to 0. So to solve question number 1, we can answer that by saying 2x plus 1 for the domain must be greater than or equal to 0. What am I doing? Greater than or equal to 0. Okay. Let's make that a bit bigger again. Okay. So 2x plus 1 greater than or equal to 0. When you solve this inequality, you are well aware you're going to take over that. You get minus 1, and you get 2x is greater than or equal to minus 1. Therefore, x itself, we're dividing by a positive. We don't have to do anything to this inequality. X will be greater than or equal to negative a half. Okay, so that will be the solution to the first question. For the second question, solve for x if f of x is equal to 2x minus 1. Now, students, don't let the function notation throw you off. The question could have been given root of 2x plus 1 is equal to 2x minus 1, and then it's going to say solve for x. Sometimes a student sees this and they forget all that they're asking here is to take this thing that you see over here and to substitute it in there, because exactly the question is telling you that. They're telling you if f of x is equal to 2x minus 1. But what is f of x? So all we're going to do is we're going to manipulate that. We're going to take this whole thing and we're going to replace the f of x with what it is equivalent to. So we're going to say root of 2x plus 1 is equal to 2x minus 1. Now remember, before we go to the quadratic strategy and before we write into standard form, the very first thing we need to look at is, do we find any fractions? We don't find any, so great. And do we find any roots? Yes, we have a root. Now the strategy when solving root questions is twofold. Number one, when you get a root, number one is you're going to isolate the root, okay? And number two, you're going to then solve. Now by solve, I mean you're going to apply, write in standard form, try to factorize, and or use a quadratic formula. My apologies, it's all over today. Okay, so what do we do over here? We're going to isolate the root, and then we're going to square both sides. Okay, and after we square both sides, we're going to solve in standard form, right? Ax squared plus bx plus c equal to 0. We spoke quite a bit about that last week. Okay, so in terms of isolating the root, I've already isolated the root. That simply means that we want the root on one side of the equation and we want something else on the other side of the equation. So we've got the root on its own. The second step is to square both sides. All right. Okay, when we square this over here, we're left with 2x plus 1. And when we square the other side, I want you to remember your rules from grade 8, grade 9, and grade 10 on squaring binomials. When you square this, it's going to be 4x squared. Okay, when you square the last term, it's going to be plus 1. And then you multiply the product here, and you're going to get negative 2x, and you multiply that by 2, and you're going to get negative 4x. Okay. At this point, the agenda is to have everything in standard form. So I'm going to make this 0. I've got 1 and 1 cancelling out over there. And when I have 1 and 1 cancels out, what do I get? You see, if you got the same thing on both sides, same signs, or if you want to say you take it over, that's going to cancel out with that. I then have 4x squared minus 4x minus 2x gives me minus 6x. Right. Now, once it's in standard form, you can clearly see the c value here is 0 because there's no c value. The next thing you also need to note with this over here is standard form, first try and factorize. And then the golden rule with factorization itself is always look for the common factor. Before you try fancy trinomials or difference of squares, always look for the common factor. So over here, there is a common factor of 2, right? So you could pull that out if you want to. So 0 is equal to 2 and x. So 2x is a common factor. And what do I have over here? My apologies. Multiplied by 2x. And 2 times what gives me 6? 2 times minus gives me, and this will be 3, right? So 2x minus 3. Okay. Right. Yeah, that makes sense. Okay. Okay. So now we can see we have 3 factors here. The first factor is 2 or 2x. The second factor is just x. The third factor is 2x minus 3. You then can say that x is equal to 0 because that's the one factor equal to 0. This is the other factor where you can clearly see 2x minus 3 equal to 0, which means x is equal to 3 over 2. However, remember now, something that we have to be very careful about. We have to go back. And this is often the last step that students miss because a question like this, I'm just trying to see, is worth 5 marks, right? And you must also indicate the restrictions here. Okay. We know the restriction from the previous question. In the previous question, when we asked what is the domain, and you can see this question is scaffolded. The domain over here is x must be greater than minus a half, greater than or equal to minus a half. But at the same time, when you perform a check, if I look at this over here, I've got square root of 2x plus 1 is equal to 2x minus 1, right? And if I put 0 in there, 2 times 0 is 0, plus 1 just gives me 1, so the square root of 1 is 1. And I say equal to, if I place 0 in here, I'm going to get 2 times 0, which once again is 0. Minus 1 is minus 1. So the solution over here, 1 does not equal minus 1, so therefore this is not one of the solutions. Okay. On the other side, when I plug that in, you can play around with it. What was it? 3 over 2. 2 times 3 over 2 will just give me 3. 3 plus 1 is 4. Square root of 4 is 2. And again here, 2 times 3 over 2 is 2 minus, was it 3 over 2? 2 times 3 over 2, 6 over 2, 3 minus 1, that also gives me 2. So clearly this is definitely a solution. So once you are done, you must indicate 2 things there. Number 1, you either show us, sometimes they show us this solution is not valid, you cross it out. Alternatively, if you don't cross it out here, you must go one step further to say, therefore, x is equal to 3 over 2 after you've done this check. Okay, now let's be a little bit of a merchant once again. If we take 5 divided by 150 is 1 over 30, and 1 over 30 will be 0, 5. It's 5. So 1 over 30 times 100, that's going to be 3,33%, right? So a question like this is not rocket science. It's something you can do at grade 10 level already. You must master these marks. It's easy, right? Very, very easy. Isolate the root and square both sides. And be careful here because many students, they make that common error. When they square this, they write 4x squared plus 1. So in other words, they square the first term, they square the last term. No, that is not what you do, right? Sometimes they write it out the long way and they also come to the same solution over here. But remember, you're going to square the first term, square the last term, multiply the inner products, and then double it, and you get the middle term, right? Okay, let's do one more question like this quickly, and then we'll move on to inequalities. Before I continue, I just want to pull something here from the diagnostic report, and let me just check which year is this. This is 2022, and let's see what the examiners wrote about this. That they wrote over here. This is what they wrote, right? They said, most candidates had some idea that they had to square both sides of the equation in question 1.1.4. However, few candidates were able to isolate the surd before squaring both sides of the equation. The following errors were noted. Okay, so what were the errors noted over there? They noted these errors. So what I'm going to do is I'm going to pull up this question quickly. Let's just find November 2022. That's paper 1, right? So yeah, we've downloaded it quickly. Okay, so let's look at that question. This was question 1.1.4, and they're saying students often did not isolate the root, right? I just want to write down. So question 1.1.4, fairly simple question once again. We can apply those 2 steps and let's see what we get. Where's my marker? Okay. Let's just see. Okay. Right. So let's just make some space to work that out over there and see if we can actually draw over that. Okay. Oops. Ha. Okay. So let's go red and then let's just get our pen back to a reasonable. Okay. So remember this question. Clearly, I see there's a root. We don't want to work with the roots. Ultimately, my objective is to square both sides and write in standard form. Now, again, we saw students made silly errors here. We heard about the common mistakes that was made. Now, step 1 is to isolate the root. So this whole thing on its own is a term. That's something we need to remember. Okay? That whole thing is a term. That entire thing is a term on its own. Okay, so that means we can move it around. So when we move this around, I will have x. I'm going to take the 12 over, so I'll have x plus 12 is equal to, I'm going to bring that to the other side because I just feel like a positive number with that root over there probably be a little bit better to work with. Root of 7x. Okay, so that's what we want to see. Now that was our first step. The very first step that we encountered here was to isolate the root, right? Number 1, isolate. Okay, number 2, square both sides. Okay, so when we square both sides, we will square this over here. We're going to square that over there. Now, squaring this, once again, don't make that error of squaring only the one and then the other term. Remember, it's first term squared, which is x squared, last term squared plus 144. Multiply the insides, that's going to be 12x, and then double it, and I'm going to get then plus 24x. Okay, so that's a little bit too thick. Okay, on the other side now you must look very carefully. That's going to be 49x. So that's going to look like this, 49x. How did I get that? I want you to remember, if I've got a times b, you've learned this in grade 9, all squared, then this is equal to a squared times b squared. In other words, the first factor squared, and then the second factor squared. Now, you know 7 squared is going to be 49, and you know the root of x. When you square that, the root part falls away, and I'm left with 49x. Now, again, this is not standard form, so don't try to factorize at this point, okay? Standard form, I need it equal to 0. So when I equate this to 0, I'm going to have x squared. I've got 24x and 49x. That's going to cancel out with 24 over here, and I'm going to be left with, what is that? That's going to be minus 25x, right? Plus 144. Okay. Now, let's just make some space over there in that question paper once again. Righto. Okay, factors of 44, I must add to give me 25. Factors of 44, I'm 144 that I add to give me 25. 10 times 9 is 90. And 6 times 9 is, what's 9 times 6? 54. So 54 and 90 gives me 144. So my factors will be x and x, right? What did I say now? 10 and 6, 16. So let's just put in the signs in the meantime. Same signs, both will be negative. We'll take the sign of the middle term because the last term over here is positive. And then I'm going to have 10 times 9 is 90, 6 times 9 is 53. So that's going to be 44. So that's going to be 16 and 9. Okay. Remember, you can always use the calculator here as well. But remember, try and factorize. Okay. Okay. So therefore, my values of this is going to be x is equal to 16 or x is equal to 9. X is equal to 16 or x is equal to 9. Okay. And at this point, you can easily just put that in a calculator, double check your values. 16 minus 7 times by the root of 16. That gives me negative 12. The other value was 9. So minus 7 times the root of 9 is also negative 12. So always, once again, check that when you substitute in the values, it works at both sides of the equation. So this is correct and this is correct. Now, again, remember that this was 4 marks. A question like this is 4 marks. 4 out of 150 is going to be more than 2%. In fact, it's 2 2/3 percentage, so 2.27%. So I want you to think like a merchant. Everybody can, at the very least, pass mathematics. Okay, so these are your core examples of what we looked at with this. Remember what the diagnostic report said from the examiners? They indicated the following. Just bring it back over there. Common errors. Some students had 144 on this side. Some students had x squared minus 49x. Now remember, this isn't 100% correct here either in the manner in which they squared both sides. I mean, if they did square this and they squared the side correctly and then did it in standard form, they would still get the correct answer. But here they made one of those common errors. Okay. And some things that other students also did. Yeah. Anyway, let's move forward quickly. Let's talk about, we've got the examination paper here. Let's look at what we brought up on the side. Yeah, sorry, it didn't look like the exam paper to me for a moment there. Let's look at question. We're going to look at the inequalities shortly. But just before we do that, okay. Question 1.1.3. My apologies, guys. 1.1.3. So when we look at question 1.1.3 and we go to the diagnostic report again, and we look at what we have over here, 1.1.3 from last year's paper. Look at question 1.3. It's labeled incorrectly. It should have been 1.1.3, right? 41% of learners were able to do that question, right? So if we go back to this report and we want to see what they said here, and this is what we're going to focus on next. We're going to do some inequalities, right? Yes, in question 1.1.3, many candidates treated the inequality as an equation. Big error. Inequalities are not equations, okay? The answer read x plus 9 multiplied by x minus 10 is greater than 0. Once they were done with that portion, they then indicated x is greater than minus 9 or x is greater than 10. Many candidates struggled to interpret the correct answer from the inequality, okay? So they said x plus 9, x minus 10 greater than 0, therefore x equals minus 9 or x equals 10, and then they threw it between two intervals, x is greater than minus 9 and less than 10, okay? That's not the right answer. So some candidates drew a sketch but were unable to use it to write down the required answer. Another common error was the incorrect notation in the answer. Candidates wrote x greater than 10, x greater than minus 9. So we need to speak a little bit about this as well. Or they wrote, yeah. Anyway, let's come back to that. So why I showed you the diagnostic report here, if I go to 2021, obviously there's learning losses and things that we're looking at from COVID. In 2022, this percentage of 41% of such a basic skill is highly disappointing. Even 1.1, for the country, this should be 100%. For 1.2, this must also be 100%, because this question over here is really dealing with skills from grade 9 and grade 10. You know the zero product property, you know how to factorize, you know how to solve a trinomial, okay? So these first two questions in the exam should not be less than 100%, but compared to everything else, it is answered fairly, with a fairly high mark. Question 1.3, the inequalities year in and year out, we see as something that learners underperform in. Now, 41% is slightly higher than the previous year, where we saw a statistic of something like 16%, which is just crazy, because what you'll see today in the next 17 minutes is that inequalities are fairly easy to solve. However, learners must practice. Okay, so let's get on with that. Okay. So let's take basic inequalities quickly. And screen, we've got something for you there. Okay, so what do we have? So let's look at that first one. X squared minus 3x is less than 4. X squared minus 3x is less than 4. X squared minus 3x less than 4. Okay, I'm going to write that over here. X squared minus 3x is less than 4. Okay, how do you solve this? Well, to solve this inequality, let's make it into something we can understand. X squared minus 3x minus 4 is less than 0. Okay, now when you get this inequality, most students are fairly capable of getting to this point over here. But then, as the examiners noted, and in the diagnostic reports, is that students are treating this like an equal to sign. However, we must factorize. So we factorize next. Okay, and we say factors of 4, we must minus to give us 3. That's going to be 4 and 1, x and x, right? Minus 4 plus 3. Okay, at this point, so many students will write down x is equal to minus 1 or x is equal to 4. Now, please note, these points that you've listed here are important, but it's not the solution. Okay, we call these the critical values. Okay, now if you were to graph this and you had to draw this as a parabola, remember this here is an algebraic expression, right? Representing a particular graph or a particular function. And that function looks like this. It cuts at minus 1 and at positive 4. Okay, minus 1, positive 4. And what is it actually saying? When we ask you this question, we're asking you to solve for x. If this question read solve. Now, there isn't a specific value of x that is true for this. In fact, it's rather an interval that holds true for this. So what we mean over here is multiple values, when I plug them into x, will pop out some kind of value that is less than 4. And that's going to be your solution. So when you use the critical values are meant to be used in order to find the final solution. It is not the solution. You're not going to get marks if you write this line. So generally, I might advise a student do this off the page or indicate that those are the critical values. So there's minus 1, there's positive 4. What you must also note is that x squared minus 3x, I could consider this to be f because it is a function. So then f of x, the function in terms of x, is less than 0. This here refers to your y value. Now, everything above the x-axis, that is going to be f of x greater than 0. And everything below the x-axis, please note, is f of x less than 0. Another word of saying less than 0 is the word negative. And over here, indicating the word positive. Okay. So how do we solve this? Important to draw a diagram or to use a number line. So for quadratics, a diagram is fairly simple. When we go to higher order polynomials, then a number line becomes a little bit more important. Okay. Now, this here indicated less than 0, right? Less than 0. So what does that mean? the function is less than 0. In other words, all the y values are less than 0 across this interval over here. That's the part of the function I'm interested in. But when they ask you the question, we're asking you what values of x, when I put into this expression on this side, will yield a value that is less than 0. That's going to be any of the x values you see in between -1 and +4. Any of those x values, right? But we want so we then look at that interval. On a number line, it's going to be open, and this is also going to be open. You've covered this in grade 7, 8, 9, and 10. And then we're interested in that interval. Now, that interval is all the numbers here. We say x, all the numbers here is going to be less than 4, and all the numbers over there are going to be greater than -1. Now, why am I not coloring it in? Because if I color it in, the end points over here, then it's going to be equal to 0. Okay, so we'll do that one next. Okay, so there's your 4 marks. 3, 4 marks, easy peasy. You factorize, you find your critical values. Most students can get to this point. Please don't write things like x plus 1 less than 0, and then you say x is less than -1, or you do x minus 4 is less than 0, therefore x is less than 4. This is not the solution, right? This is not the solution, because when you did that, you were applying what we taught you last week, the zero product property, which is when we have something multiplied by something else equal to 0. This is not the solution. You find your critical values, you draw a diagram, or you use a number line, and you see where is the function positive, where is it negative, and you read off the values from the x-axis that yields your final solution. Okay, so these are 4 marks, guys. Let's do another one quickly. Remember not to treat it like an equal to sign. Okay, so let's take the same one and just show us what will happen. X squared minus 3x less than or equal to 4. Once again, we have x squared minus 3x minus 4 less than or equal to 0. We then factorize, and when we factorize, we're going to have factors of 4. I'm going to subtract to give me 3 is 4 and 1. Minus 4 plus 1, x and x. And therefore, my critical values, which is not part of the solution here, so you can do it off the page or you can go straight to your diagram. I'm going to have this diagram. I can list the critical values over here as x equals to 1 or x equals to positive 4. And that's, my apologies, negative 1. So negative 1, positive 4, right? Negative 1, positive 4. Now, here, the question was less than or equal to 0. So once again, we are interested in this interval over here where the function is less than or equal to 0. But in this point over here, it's going to include that interval over there. And it's going to be everything that this leaves a shadow on the x-axis with, right? So look carefully. Whenever I take 0, or I take 1, or I take 2, or any number in between -1 and positive 4, then the output value of the function of this value over here, sorry, not that value over there, of this thing over here will be negative, right? It will pop out something that's at the bottom. Okay, so the answer here is x will be less than or equal to 4 and greater than or equal to -1. That's my interval. Okay, so let's look at another question very quickly. In these 10 minutes, please go over inequalities. No student should get an inequality incorrect in the final exams, right? Getting this wrong, it's criminal. X squared minus 3x is greater than 0. Let's make it greater than, let's just make it greater than 0. Okay, so x squared minus 3x is greater than 0. Now, if we look at this graph once again, I'm going to factorize x into x minus 3 is greater than 0. So what does this look like? Okay, once again, it's a parabola. The critical values for this parabola is x is equal to 0. I get that from this factor over here. And the other critical value, x is equal to 3. And if I look at where 0 is over there, right? So if I draw it, I've got 3 over there and I've got 0 over there. Okay, I don't have an equal to sign, but now they asked me greater than. This is where the function is greater than 0. It's everything on top. So if you look at that very carefully, see what I'm coloring in over here? What I'm coloring in over there, right? And what I'm coloring in over here, everything that you see over here is where that function is positive. And everything that you see over here is where the function is positive. But what I want you to think about carefully is this portion over here, that y value, that output of that graph leaves a shadow on the x-axis, right? That continues on over there, because if I extend this, it goes on and on and on. And these are the x values that you must put into that function to get out a positive value. Okay? We all understand that, I hope. Okay? Because once again, this x over here corresponds to that y over there. This value that you find here will yield that positive y value over there. And then similarly, everything that you see on and over here and going past here, everything after 3, when I plug that into x, will yield a positive value. So you see, we indicate positive, color in above the graph, read off the x values. So that's 2 intervals. It's not continuous. And 2 intervals means this side over here, the one solution is x is less than 0 because it's all the numbers to the left of x. And on the other side, the other solution is all the numbers x is greater than 3. All the numbers or all the x values to the right of 3. Okay, now let's go to a trickier one. Let's see if I can pull up a trickier question. Yeah. Of course, if we had equal to there, it's also going to be fairly simple. So now I just want to bring up something because we said a common misconception is learners not flipping the inequalities. Let's just see quickly. Let's see what I have for you over here. Okay. Here's a question. Let me just see what I can pull up for you over there. That comes from also the 2015 examination. Okay. Now, we must be careful not to work in a circular direction or motion or so, right? So let us go, and we're going to solve this question in 2 ways. So I've got x minus 3 into 2 minus x. X minus 3 into 2 minus x is greater than 0. Now we must be a little bit aware of what we see happening over here, right? If you multiply out this full thing, if you multiply out everything, then if you multiply out everything, you'll get some equation, right? And when you get this equation, you're going to see a graph that is, you're going to find a graph that is upside down, right? Here we go. So let's just bring this up quickly. And let's give you an example. Y is equal to, and we look at that function x minus 3, 2 minus x. Right, so already there, students were thrown off a little bit, just a little bit. Can you see what this graph looks like? Now, when we see this graph, we can see that everything after 3 yields a negative value, and everything before 2 also yields a negative value. Everything after 3 is negative, and everything before 2 is negative. Okay? And this question wanted you to solve where everything is positive. So if we think about everything being positive, our solution is going to be x between these 2 points. Just look at it very carefully. The graph itself is positive when the x value is more than 2 and when the x value is less than 3. In other words, any value of x that you throw in between 2 and 3 will yield an output of some positive y value. But if I take the number 1 and I plug it in that equation, then I'm going to get -2 as a solution. So the solution here, graphically, I can read it off and I can say the solution to this question is going to be x is less than 3 and greater than 2. Okay, but now what I also want you to remember is we need to solve this question. Okay, we need to solve it. Okay, now one way of solving this is I'm going to swap the factors. I'm going to make it 2 minus x, and I'm going to make it x minus 3 is greater than 0, right? Remember, we want to see, can we get to the same question? Because I used the graphing calculator right now to kind of take a little bit of a shortcut over there. Now this over here, 2 minus x, if you are thrown off by this about what the graph will look like, then factor this out and say, okay, I can swap that around to x minus 2, leave this as x minus 3, greater than 0, but now there's a problem over there. The problem is I've actually changed the question. And if I've changed the question, I can't really do that. I'm not allowed to do that. I can't change the expression. I must fix what I've just done. So to fix that, I place a minus in front here. Okay, you learned this in grade 9. So if I've got a minus in front of here, minus times x gives me the minus x. The minus times minus 2 gives me the positive 2. So everything is intact over here. Okay. Right, so everything is intact. Now when I read it, I see that this looks like a into x minus r1 multiplied by x minus r2 is greater than 0. So you know this is still just a parabola, right? And you also know that this little a over here is represented by a is equal to -1 in this case. And if that's a negative, guys, you know that for a parabola where a is less than 0, the parabola is upside down, sad face as some teachers call it, or it's a smiley face when a is positive. So when you draw this, you can immediately see now my critical values here is going to be, once again, when I draw this parabola, my critical values are going to be 2 and 3, right? X equals 2 is one of the critical values, or x equals 3. These are, once again, the critical values. They are not the solutions to this question because the solution is a full interval. So when I draw the parabola, I draw the wrong parabola. When I draw it, I'm aware that because I've got this negative in front over here, the parabola is upside down. And because it's upside down, I'm going to draw a parabola that looks like that. And I know that that point is 2 and that point is 3. I could have drawn 2 and 3 first and then indicate the parabola over there. Okay, so students, now that I've got the correct graph, I go and I look and I see they wanted greater than 0. So that's everything on top. That's greater than 0. This is less than 0. But I color in over here. And I see that the shadow of what I've colored in is this entire interval on the x-axis. And the endpoints of 2 and 3 are not included because it doesn't have an equal to below. So I'm going to have an interval where my x value is going to be less than 3 and greater than 2. And that's my solution. Okay, right. So what other way could we have done this question? Is there another way? There is another way. And let's wrap up with the alternative where we see that we have the same solution. If we come from this point over here into x minus 2 into x minus 3 negative is greater than 0. Now let's say you were uncomfortable as a student just drawing an upside down parabola, you forgot something here and you want to get everything positive over here. You and I both know that one way to do that is to multiply everything by -1. So if I multiply this entire side by -1, that negative is going to fall away and I'm left with only x minus 2 and x minus 3. And I've got the 0 on this side. But when we multiply or when we divide an inequality, this is an inequality. When we divide or multiply an inequality by a negative, this is negative is already here. I'm going to multiply everything by negative and then that negative falls away. I'm supposed to swap the inequality sign. Now, if I swap the inequality sign and I draw this graph, remember this graph with a minus in front is going to look like that, okay? Going to look like that. But this graph with no negative a value, the a value over here is positive. There's a positive there now. That's going to be a smiley face. Okay, so righto. If we draw this one, there's my graph. I again know the critical values didn't change. It's still going to be critical value 2 and critical value 3. And when I put that in, my graph's going to look like that. There's my 2, there's my 3. But because we applied this negative over here, we know that the inequality changed where I needed to find less than 0, and everything less than 0 is this over here. That's my less than 0 part, and the shadow of that on the x-axis is between 2 and 3, so therefore x is less than 3 and x is greater than 2. Okay. So, ladies and gentlemen, that brings us to the end of today's session. We hope that you found it useful. We covered a little bit of number sense. We've done some of the giveaway marks, and by today, having covered zero product property and some strategy last week, I think 4, 8, 12, you're looking at 12 marks roughly out of 150, and that gives you 2 out of 25, which is 8%, right? 8%. Give or take, it could even be at potentially almost 10% of the paper. Okay, but please look after your inequalities, look after your simultaneous equations, look after the basics, ensure that you're able to factorize. Make sure you get all the marks that are coming from your grade 10, grade 11, and the work that is from the previous grades, right? Matric maths, it's not difficult at all, but it does take some grinding. And remember, even with questions like these inequality questions, students know this work. They understand the work. However, they're making the errors because of practice. They're not practicing this. So when this same student does this and they're around the teacher or they're taking their own time, they can get the full marks of the inequality. But as you saw from the diagnostic report, only 40% of the country managed to score the marks in that question. And that's an improvement from the previous year, where 16% of the learners in 2021 were able to get full marks in the inequality question. Okay, shukran to everybody, and we hope to see you in the next session, probably later this week or next week, inshallah. Over to Brother Amir, who's back in the studio.
MashaAllah, we say shukran, jazakallah khair, and by terima kasih, thank you very much to Brother Iman Isaacs from Futures Academy, SA's online high school, also beautifully giving over the discourse for this particular section, and that pertains to mathematics, paper 1. I was just looking at some of those equations and I could see how hectic it might get, but at the same time, with great practice, inshallah, all of you, our beloved matriculants, will be able to manage, not only manage, but you'll be able to succeed in doing very well at your examinations. And with that said, inshallah, just before we end off, we wish each and every one of you, all of the matriculants out there, very well with your examinations. May God Almighty Allah grant you all the success with your examinations. And we say shukran and thank you very much, firstly, to Brother Imad for so beautifully conducting today's session on paper 1, mathematics for algebra, for all the matriculants, for the trial examination. And of course, thank you very much and shukran to each and every one of you, our beloved viewers, for tuning in today, inshallah. And until tomorrow, inshallah, we wish you all well, not only for the examinations, but we also wish you well for all of your future endeavors, inshallah ta'ala. From our side, we will sign off. And as I said, until tomorrow, when we continue with the next session, inshallah, the last reminder from our side is, as always, please, if you know of students out there who are struggling, who are in matric currently, who are doing mathematics, please forward this link to them, inshallah. Share this with them on the Facebook page as well as the YouTube page of the Voice of the Cape. This is the Voice of the Cape's Matric Annual Revision Program in collaboration with Futures Academy, and that is South Africa's online high school, alhamdulillah. From myself, we sign off and we say until tomorrow, inshallah. Wassalamu alaikum wa rahmatullah.
Salam.